Welcome to the class on artificial neural networks. In this video, I give a short introduction to supervised learning. So we have seen that an input image is put into a classifier and gives out a network output, a classifier output. A classifier could be a neural network. I denote the actual output of the network by y hat. Y because it's an output, hat because it's sort of an estimate of something. Now it's called supervised learning because we assume that a supervisor, a teacher, has already looked at this data point and said, oh yes, this is a car. So the supervisor gives a target output t mu for this input with index mu, t mu equal 1. More precisely, supervised learning needs a database where you have p data points, and p should be a large number, not just 10, maybe 10,000, maybe 5 million. P is a large number of data points. Each data point consists of an input, this is my vector x, together with a target output. The target output is what the supervisor gave as a label. And t mu equal 1 means, yes, in our example it's a car. T mu equal 0 means, no, it's not a car. So we have these many data points in the database of supervised learning. So for this input here, the teacher said, yes, it's a car. This input number 7, the input vector number 7, has a target output 1. But our classifier currently says the output is 0. And this means that the classifier is wrong. We have an error. And the aim is now to change the parameters of the classifier such that this error is as small as possible. So we work with a database for supervised learning. We have our p data points, we have an input, and for each input we have a target output. Now for each input, our classifier gives also an output. That's its estimated output, the estimated label. And we use errors, if the two are not the same, for optimization of the classifier. Now these errors are often used to define the loss function. And I will just give an example very generally on the next slide. And then I want to make one remark, and that is, here I work with just one class, car or non-car. So this is just binary 1 or 0. For multi-class problems, these targets are vectors. So it's it could be a house or a tree or a car or a bird. And then the target would be that only this output, this component that codes for car sets to 1 and all the others are 0. To summarize, supervised learning needs a database where we have input together with a target output. So it means data is labeled. It means it's costly because a human annotator has to go over the data in most cases. That's the first thing. The second thing is we need a way to measure errors, which means for a given input x mu, we compare the classifier output with t mu. And the usual way of doing this is that you define some function of the difference between y hat mu, the actual output, and the target output, and then you sum over all data points because you want the error to be small for each and every data point. And then we need a method to minimize the errors, and to do that we would adapt the parameters of the neural network. And the first method is shown in the next video.